Okay. Hello, everyone. My name is Ahmed Hasham. I'm an assistant professor in Arkansas State University. And we have Mr. Matthew Morris. He's Arkansas grower in Central Arkansas. And today we are going to speak about use of drone multispectral imagery for variable rate fertilization in Central Arkansas. The outline for today's presentation, I'm going to speak about introductions, objectives, growers' perspective on using drones, and advantages and disadvantages, methods and result and discussions, and we're going to speak about conclusions and recommendations for each objectives we have for this presentation. As all of us know, nitrogen application is essential to maximize or to improve your yield production per acre in vegetables, in fruits, and also in row crops. On this presentation, we are going to focus on rice and corn. So rice yield and milling quality has a relationship with nitrogen rate applications. But to what extent we should increase or reduce our nitrogen applications for the grower benefits. And the last point, we're going to speak about the drone imagery and sensors in precision agriculture applications and what kind of benefits. And we're going to hear it from a grower perspective related to precision agriculture, how it's going to be beneficial in terms of field scale applications. So the overall objectives for this research was to develop variable nitrogen rate prescriptions using unmanned aircraft systems for corn and soy and rice. And the second objective for this research is to assess variable nitrogen rates on rice yield and milling quality, because these are crucial questions for growers to be able to assess yield and milling quality with different nitrogen rates, and until the point it's make the best economic effect for growers. So let's now hear about growers' perspective in terms of using drones and precision agriculture.
So first, I'd like to talk about what it means to myself as an agricultural producer, what it may mean to others that are watching this. Some of the things that benefit us as the producer are to be able to see that this is the future of farming opportunities. This is somewhat cutting edge technology, and we are able to have drones ourselves as farmers that are not extremely expensive. They're a fraction of the cost compared to the research drones. And having those drones, we are able to use them for many different things. They help us when we optimize our inputs to be able to either save money on the front end, obviously to make money on the back end of it. And also, as we make decisions throughout the growing season, we are able to use these drones for many different things to our benefit. One thing is that we have the drone to use as our personal device where we can make decisions faster. We can determine what we need to fly certain fields for certain reasons, and then turn around and ourselves use those results to react quicker to certain things that we may need on the farm. And also, our drones are not just for multispectral use. They can be used for many other things. I personally have used them for the last couple of years as I irrigate my rice crops, and I'm using my multiple inlet irrigation. I have used the drone to determine how to irrigate better. make maps with the regular camera, and then study those maps as I'm starting to irrigate to determine how to adjust my gates in each paddy. And that's what the other main thing that I use the drones for. And that can be the multispectral drone all in one package. It has a standard camera that you can use with it. Also, other people are using the drones to survey, especially now here with polypipe being put out on our row crops. The RTK drones have been used to do elevation surveys. So that's another thing that we can use the drones for. For us, we have found on our farm that it has been a very, very good investment. And again, at the fraction of a cost of a research drone, it gives us the results that we need. And we have been very, very satisfied with it. We have found that we learn a little bit every season that goes by. So there is a learning curve, but it is a lot simpler than what some would think to get started using these drones for these newer technologies that we are starting to see in the farming community.
Yeah, and how easy it is when it comes to using drones and in farms.
So when you purchase a drone and you wonder what all can I do with this besides taking photos from the air, there are several different applications that you can use with the drone. It's a fully autonomous flight. You don't have to fly it yourself. There's several different options out there at several different price ranges, and basically, if you can draw your field border, then the software will take over and it will do all the rest for you. So just starting out with some of this stuff, it's not as scary as it sounds. Am I going to crash my drone? You know, I've spent all this money, I don't even know how to fly it. There's the way the technology is now, we actually are not doing very much except for getting it set up, and then after the flight we're doing the processing of the images, which is just a matter of taking the files off the drone and putting them in your computer into the software that you've chosen to use. This kind of stuff can seem like it's a lot, but honestly, you can get it as basic as you want to, or you can grow into the more advanced options as you continue to learn.
Okay. So for the first objective of this research, to develop nitrogen rate prescriptions for corn. The reason for this, inside the field, we have soil variability, and in each field or in each area, we have to treat it differently instead of applying a blanket spray. So for this field, we have 52-acre field. The soil is silty loam, and decalb 6744 was the corn variety planted on this field, and it was planted on May 2nd. The nitrogen rate was 54 pounds of nitrogen per acre. So in terms of urea, it's 100 pounds urea per acre. And we developed the prescription for this field. We have used the M210 drone equipped with the multispectral and thermal sensors called the Altum sensor. We fly at 7-day temporal resolution, depends on the weather. We flew at 400 feet above ground level, and the flying speed, it ranges from 10 to 12 meters per second. So in other words, if you have a 70-acre field and you fly at the speed of 12 meters per second with this drone, you would be able to cover a 75-acre field in 30 minutes. However, Not every day is a perfect day to fly. So if you have cloud, if you have shadows, you have to reduce your speed a little bit. And the sky is clear and the wind is not blowing fast, in that case, you can increase up to 12 meters per second flying speed. At 400 feet altitude, we were able to obtain up to 2 inches spatial resolution. And this means we were able to see up to 2 inches of the ground using this drone and sensor. As Matt mentioned, we, after flying, just only the matter of getting the imagery from the sensor and insert it to the computer, to the software Hex 4D mapper, as you can see here. This is to stitch the images. And after we stitch, we are using Hex 4D field to be able to develop the prescriptions. Very easy to use and user-friendly. And after you draw your prescription, you can share it to your grower, share it with your ag pilot to be able to load it to the machine. However, as I mentioned, not every day is a perfect day to fly. So we have seen some flying challenges. And the biggest question for a grower, what kind of regulations should I follow? So the basic thing is you have to obtain your remote pilot license. And this is from the Federal Aviation Administration. You have to obtain your Part 107 remote pilot license. You have to be careful when you fly with drones for research or for consultants or for farmers, because we have two categories in flying. You have categories of flying for hobbyists or flying for commercial. So flying for commercial, like when you work for a grower, when you are working in a university, when you are working on a research project, so this considered commercial. Flying for hobbyists, when you are running, when you are going for fun, for vacation, this would be for hobbyists. For our case, you have to obtain your remote pilot license. After you obtain your remote pilot license, you have to look for if the airspace is controlled or not controlled in the area you are going to fly. How can I know this? There is a website called Sky Vector I'm always using to check on all my aircraft flying locations. And this I have to check one time to be able to see if I'm allowed to fly in a certain area without a permission or not. If you are not allowed, you have to make your arrangement early in the growing season, because if you are flying near Memphis Airport, you have to submit your request ahead of time before the growing season to be able to fly. Let's say you have your pilot license and you are clear in the airspace, you have to make sure that you have the experienced pilot who's going to fly, because you don't want to get just a recent pilot who has no idea about drones, and it looks like cause for you a problem in your farm. The weather is another big thing. So as here in Arkansas, it's kind of raining in the summer, and some days we can fly maybe for a week or 10 days, but maybe in some weeks we can fly twice. So it depends on the weather. You have to maintain the 7-day temporal resolution as much as possible. Setup time, and this is including if you are traveling from your office to the site, maybe in Carla or in Hamanok or in Manila. It depends on the location where the fields are. And once you arrive there, maybe take 10-15 minutes until you assemble your drone, get the sensor, run the calibrations, and make sure everything's working fine. And the last challenge in this set is the equipment failure. So in some instances, the sensor maybe stop recording images while you are in the field. This is just maybe happens one each maybe 50 flights, but you never know when this is going to happen to you. So in that case, we are always prepared. If you are flying, make sure you are check the data on the field before you start to drive back to your office. So these are kind of flying challenges we have seen. Another big challenge here in Arkansas, air applicators. And this is kind of very potential danger, especially if you're going to use drones for research. As you can see here on the image on the left-hand side, you can see the air applicator literally is about the crops. And based on the Federal Aviation Administration, this considered breaking the law, because the minimum flying altitude for these crops or for these air applicators is 500 feet. Let me just explain to you. So if any manned aircraft like this, it has to be minimum of 500 feet. This is literally above the crops, maybe 5 feet or 10 feet. So in that case, even the ag pilots, they committed mistakes. As a drone operator, you have to get out of their way. They have the right of way before us. So that's why once we have a good day, everyone will be flying, including drone operator, including ag operators, include everyone. So you have to be careful when it comes to flying with crop applicators on when you're flying. I have a short clip here. I'm going to share it with you to show you how it looks like here in Arkansas. So this shows you how it looks like they are flying at very low altitude and can be a potential danger for your flying mission while you are flying. Another big thing happening here in Arkansas, waterfall. And this happened with me in Hammonok when I was flying there. So while the drone was flying, on the last corner of the 70-acre field, I found this cloud of waterfowl coming across the field. And in that case, you have to cancel your mission and bring the drone as soon as possible to be safe for the drone and you don't lose your drones while you are flying. So now let's speak about the results and discussion out for the cornfield. So the basic line, you don't make a decision based on one index. You have to look for multiple indices. So in that case, we are looked for enhanced vegetation index, and this flight was in June 18. And on the same time, we looked for the green chlorophyll index on the same day. As you can see here, you can see consistent pattern of green, dark green, sometimes light green, red and yellow areas. And the red line here, this is the irrigation line for this field. Okay. If you look for the chlorophyll index, again, the same pattern is still there. And the green meaning a good standing plant because the chlorophyll index, it has a relationship with nitrogen. So as the values are high, this means we have strong vegetations. We have a weak vegetation right there. We have another weak vegetation right there, and so on. So based on this map, we started to use the software to be able, in my office, to be able to make zones inside this field. So we have the first zone, second zone, and we have 9 zones inside this field. And as you can see here, I have the zone and I have points inside this. So in that case, I'm not asking Matt to go and walk the field random. I'm asking him, please go to this point and collect the tissue sample for the plant on this location because these points were going to be representative for this area. These points were going to be represented on the second area and so on. And what I did, I developed for him a points shapefile like this with a guidance line, and I shared it with him, and Matt is going to share with you how he used it to collect the tissue sample.
Right, so as Dr. Hasham said, he created these zones from his computer in his office, and we looked at them together and hand drew out what we believed to be the zones that you're looking at right now. We felt like that was a good representation of the variables that were across the field based on the drone imagery that we were receiving. So you can see that we have 9 zones, and we decided in those 9 zones, where do we need to place the points? That would give us a good place to go and pull tissue samples. So we could send those to the lab and have them analyzed. They give us an idea of just what we're looking at, comparing that to the images that we're receiving from the drone. And as you can see here, we have the points in the zones, and he was able to put those into a file that I was able to open in Google Earth and used my phone to be able to go right to those points. That saved me a lot of time trying to walk through that corn. And some of the points that we have that were in some of the areas that were less desirable, at the top of the field, you can see where it's red. I knew I was getting close to that area as I was walking through the corn, because I went from walking through maybe 6 or 7 foot tall corn to all of a sudden coming up to maybe 5 foot tall corn. And then I just had to go to the point that we selected. And again, using my phone as guidance, I was able to go to those points and collect the tissue sample that we needed to send to the lab. After we sent those to the lab, we got the results back fairly quickly, and we were able to see, okay, here is the percent of nitrogen from those tissue samples, from those points that we selected. And then we were able to use that in reference to what we see on the map to give us an idea of how should we go about applying our variable rate application on our next step. And you can see here that we decided to zone the field into 3 zones on the variable rate map. Now, this software that we're seeing here is the Pix4D field software. It is used to view the maps and also to make the prescription maps that you need. We could have made this any amount of zones that we wanted to, but we felt that 3 was the best representation as far as how we needed to break down the amount of fertilizer being applied. So one thing that we see is that around 9% of the field had 0 nitrogen application because the plants did not need it there. And that is one of the things that by using practices like these, that we are only applying fertilizer where we need it, but also we're changing the rate in those zones as the plant requires that much fertilizer to be able to grow at its maximum potential.
And how it looks like for a grower perspective when you're using and cutting 9% of your area without fertilization?
Across the entire farm, one could only imagine if you have 9% here, maybe 15% here, just some of our fields that we did on our own, not research fields that we just did on our own, we may have 20-30% or more of the field that we didn't have to add any nitrogen to. And we knew that it didn't need any because we were looking at the map. We were looking at the images we were getting from the multispectral. So it wasn't a matter of guessing. We knew for sure that plant had everything that it needed in that area. So when you add those things up across your entire farm, you can imagine that number kind of gets on up there where you're saving quite a bit of money, and you're not having to put that fertilizer out where it may just be in the environment.
After applying this nitrogen shot, this is 1 week after. So in June 24, as you can see, we started to see the red spots right there started to catch up with the remaining of the field. Another week later, and you start to see it's coming to be start to catch to the green, and it keep going on until the end of the growing season. And that's what we are trying to add exactly what each acre need inside each one of the fields. So for the first objective, conclusion and recommendations, we were able to use drones for fertilization prescriptions. And drones are essential to apply nitrogen as plant needs, and it also reduces fertilization costs without compromising yield. And this is a very important outcome, because maybe as a grower, he's worried if he is not adding a blanket spray, he's going to lose some of the yield. We were able not be able to compromising yield with using variable rate nitrogen application on the corn field. And this is a continuous project. We're going to continue next year, and we're going to keep practicing and producing variable rate prescriptions. The second objective of this research was to assess the rice yield and milling quality with variable rate nitrogen application. And this is a hot topic here in Arkansas with a major rice state producer, and each grower wants to maximize the yield and get the highest quality. And for this, we have a 60-acre field, silty loam soil, rice tech 7301 variety was planted on May 11, and the first irrigation was June 20th. And the standard nitrogen rate is 120 pounds of units nitrogen per acre. For urea is 261 pounds urea per acre, and the maximum nitrogen rate is 180 pounds nitrogen units, which is 390 pounds of urea per acre. And this is based on the University of Arkansas Extension recommendation for the nitrogen rate. These rates has been added in 2 steps, and Matt will going to explain how he added the nitrogen rates.
Sure. So we started at the beginning of the year, and we took our Instar soil samples and we sent those in to get our results back to see which grids needed more or less nitrogen added at pre-flood. So one thing that we did is, normally when you send in results using Instar, you will get a combined result number back. We requested to get individual results out of the 10 grids that we did in the field, so we could apply that using a variable rate technology. And our ag pilots had upgraded their hardware on their computer on their airplane, so we had a little bit better technology than we have had in the past years. So what we did was we took those Instar numbers and the recommendation numbers that they gave us, and to be able to do a variable rate at such high numbers, we put out a 100-pound blanket shot first. Then after we put out the 100-pound blanket shot, we came back with the remaining amount on a variable rate. And we'll see on the next slide that shows our plots. We have the 10 Instar plots, and this is overlaid over a drone image map that was taken probably mid-season maybe, but we overlaid that, and you can see in the top left-hand corner that says 211. Okay, so we put out the 100-pound blanket shot, and then in that grid, when we started the variable rate, would have been a 111-pound shot, followed, if we were to go straight down, followed by a 156-pound, and then a 122-pound all the way down to the bottom of the field. This is what the ag pilots told us was easier on them when they did the application, that their fertilizer gate was not trying to put out the full amount, and so it worked out better for them, and all the results that we got back showed it to be consistent. So that's how we put out our pre-flood shot. again, with the blanket followed by the variable rate of the remainder. We have those 10 plots that are the instar plots that go across the whole field. And then we have our extra plots that Dr. Hasham will tell us about, and we'll start to discuss how all of that came into play.
So for the 10 extra plots, so we want to assess the rate that the grower added compared to the maximum rate of nitrogen. So for this purpose, we have to have a control and we have to have the extra rate. So as you can see here, we have squares 50 feet by 50 feet. So this one, and we choose these plots to be able from the top to the bottom of the field to see the effect of the soil variability from the top to the bottom of the field, and each one is 50 feet by 50 feet. The extra with extra nitrogen, and the control is the normal rate that has been applied for each one of these. And when it comes to the prescription on this field, we will be able to cut up to 5% of the field with no nitrogen application on rice. So this is another very important point to be able to reach to with cutting areas without fertilization, and also at the same time without compromising yield. We have used the same drone M210 V2 with the Altum sensor. We have 7 days temporal resolution, and we flew at 400 feet, 2 inches, and again we use Pix4D mapper for stitching and Pix4D field for prescription mapping. And Mr. Ahmed will going to explain to us how the process went for after creating the plots on the map and how he implemented it on the field.
So what we're looking at here on this slide is obviously pre-flood, and we knew that we were going to make the 50 by 50 extra plots in the field. In each grid, each of the 10 grids that we had from the Instar, we wanted to make a extra 50 by 50 plot to be able to compare with. So what we had to do was we had to come up with a way to know where those plots were in the field. Now, little did we know that we would be able to see those very clearly once we started taking the drone images. But what we did was we took a piece of tin and we put it on a wood stake. We had some old levy gate sticks laying around, and we just used what we had laying around the farm. And basically what we were trying to do was we were trying to break that vegetation color. So we took that piece of tin, we spray painted it with a silver or chrome color paint, and we put it right in the center of where our extra plots were going to be. And you can see we used a lawn fertilizer push spreader, and that had been calibrated, so we knew exactly how much it was putting out. And once we had that calibrated, we began to make each of the 50 by 50 plots in each of the 10 grids, and we placed the marker in the center. Now, as I said just a minute ago, you can see pretty clearly where those square plots are. They showed up extremely well on the map, and if you were to look really close, you can see the little tiny red dot in the center of the square would be the piece of tin on the wooden stake, and that was 1 foot by 1 foot piece of tin there. So you know, all of this showed up really, really well, and everything that we did to prepare for this worked flawlessly. You can see here in this picture is when we were doing the hand harvest at the end of the growing season. What we're seeing where it's darker is actually taller, and the stalks were greener. The rice was thicker there, and that is where our extra plot is. You can almost see the outline of the square, and for us, we could see the square just standing in the field. It was that much difference. And then again, you can see on this map where they showed up on the multispectral images. And then right here is what we had outlined for our harvest guidelines. Again, Dr. Hasham created these guidance lines along with the guidance points from his computer, and he sent me the file through an email, and all I had to do was click on the file and it opened in Google Earth, and I was able to use my phone to use to follow these guidelines. And one thing I want to mention is that it was extremely easy just to be able to click one thing and then have a device that already all of us carry in our pockets or on our side to use in the field. And again, that can be used for multiple things, not just for what we're doing here in this particular case, but we can use our devices to help us and to help aid us in things such as this. So we used that and we're able to drive right to where we needed to go. We were able to harvest the samples that we needed and didn't have to have a bunch of extra equipment to do so.
And what it means for a grower when he has an application like this, you can use it with a device in your phone.
Yeah, you know, to be able to take advantage of stuff that we already have. We don't have to buy anything extra. It's just a matter of learning how to use the tools that we already have. And I think that as we continue on using more things like this, these things get easier and easier to be able to use and to understand. You can see in this picture here, I actually am holding my phone. We're sitting on a Bowman Mudmaster that's what we use to drive out to the plots. It has very narrow tires, and we were able to use the platform on the front to carry our tools with. And so in this picture here, I'm actually zooming in to the first guideline that I would just follow with my phone until we got to the plot out there, and it worked really well. And I put my phone back in my pocket. We harvested what we needed, got my phone back out, and used it again to drive to the next point. So it was really easy to use.
And for this, this is a handheld device I used for harvesting. And the protocol for handheld harvest, you have to have a 1 meter square, and you have to put it on the ground, get all the plants inside this 1 meter square, and weigh it, and get the biomass, the fresh biomass weight. And after we're doing this, we are taking subsamples of 2 kilograms to be able to process it. So on this picture here, on the left-hand side, you see Matt, and while he's helping me weighing the amount of biomass in the 1 meter square, and after we have the total biomass, we are taking subsample of 2 kilograms, and we put it in a net, right, as you can see in the back right there. And we're doing this for all the samples across the field, and we have to label each one of these samples and store it after this and to dry it. After that, we are going to the greenhouse. We put it then to dry for 2 or 3 weeks with the circulated air in the greenhouse, because some of these samples are still green, especially the extra nitrogen. So after drying out for 3 weeks, we were able to get some student helper to be able to help me with measuring planting. We are selecting 20 plants randomly out of each sample to be able to measure the plant height, number of tillers, number of panicles. And after we do this, we are threshing, as you can see on the image on the right-hand side, we are threshing. We put some samples right there. We are separated the biomass from the seeds, and we are doing this for each sample. After this, we finished all the process. We are starting to do field measurements, like the fresh weight, and we are looking for lab components or lab measurements, such as yield components, such as plant height, number of tillers, number of panicles, the 1,000 grain weight, the kernel length, the percentage of milled and head rice, and percent of chalkiness. So for the results out of this project, and the most important part for a grower, and how much impact the nitrogen is going to impact my yield. Will I get increased yield or not? So on this graph here in the top, we have on the left-hand side the yield, and on the x-axis we have the treatment. And the pink color are the extra nitrogen, and the green color, and sorry, the blue color is the control. So in that case, as you can see here, the highest difference, all the extras are higher in terms of yield. And in that case, you can see the biggest difference was in plot number 10 and 9, and it was equal approximately in plot number 8. This is in each treatment when we compare each one compared to the other. However, when we take the average of all the 10 extra plots compared to the 10 control plots, we were able to see we reached to 200 bushels per acre in terms of the extra nitrogen, compared to 173 bushels per acre for the normal rate. This graph shows the same exact information, but it is in ton per acre, just in case if you are looking for tens per acre compared to bushels per acre. Most importantly, growers are looking for percentage head rice and percentage milled rice. So in that case, we were able to see all the extra nitrogen have higher percentage head rice yield. And if you look here on the percentage milled rice, we are able to see two only controls are higher than the extra. So this tells you, even you are higher in the headed rice yield from the top to the bottom with the extra nitrogen, you have two treatments inside this field, which is the control is higher than the extra nitrogen. When we look for the chalkiness, and this is important topic because the rice quality is important, determined using the chalkiness percentage. If you looked in the plot number 1, you have the control have a higher percentage chalkiness. However, if you look for number 7, plot number 7, both of them are equal. So in that case, you have lots of other variables, not only nitrogen. You have soil variability, you have weather, you have maybe irrigation effect in terms of the chalkiness. And for the moisture content, all the extras shows higher moisture content, except only for the plot number 3 and the plot number 4, where you have the control shows it has higher moisture content for the seeds. When we weigh the 1,000 grains, and once we are processing the samples, and we started to see some plots, they have no difference. Other plots, they have a high difference in terms of 1,000 grain weight. And after drying it for a week in an oven, still the same rate as well for difference between the fresh weight and the dried weight. When we looked for the kernel length, all the treatments are kind of the same except only plot number 8, where we have shorter length. However, the kernel width is kind of varies with different treatments as well. So this is an indicator. It is not only kernel length you should look for, but also kernel width is variable with different nitrogen rates. On this slide here, this is the fresh weight biomass after hand harvesting. And as you can see in the top graph right there, you will start to see in plot number 4, we don't have much variation between the extra and the control. However, if you look for plot number 1, plot number 9, plot number 10, there are lots of variation between the fresh weight and between the control and the extra. The graph at the bottom, it shows how much difference between the two treatments in each one of the plots. So it reached up to 2.4 kilogram difference in plot number 1, and the highest after this plot number 9 and plot number 10. However, Plot number 4, plot number 8, we have the minimum difference between the two treatments. So again, to recap, we have other variables we should consider when we are looking for different nitrogen rates. These graphs show the plant height, the tiller number, and panicle number. And it also shows there are variation between the field across from top to the bottom of the field. Filled grain weight compared to the unfilled grain weight. And this is an interesting graph to see. So the top graph shows that the control in the first plot has higher filled grain compared to the extra nitrogen. However, the 10 extra under control is kind of the same. So it depends on the soil and maybe soil variability inside the field. The unfilled grain weight is also different. In the extra here, if you look there, you will see the extra has higher unfilled grain. And in number 8 here, you will see the control has higher unfilled grain. So the bottom line here, it's either depends on the top of the field or the bottom of the field. You have variations inside the field and going to impact your nitrogen application and efficiency. So the conclusion and recommendations for this presentation, the fresh weight varies between the two nitrogen rates of this experiment. The maximum nitrogen rate had higher yield than the recommended rate. The recommended nitrogen rate showed higher 1,000 grain weight compared to the maximum nitrogen rate. The maximum nitrogen rate had higher percentage head rise yield. The recommended nitrogen rate showed higher percentage of mill rise yield. Regarding the shockness percentage, the two nitrogen rates varied across the field with the dominant low shockness percentage with the maximum nitrogen rate. And for this research, if you have any questions, feel free to send us an email to myself or to Matt, and we'll be happy to answer your questions once we have. And if you are looking for credits for this presentation, here are the instructions to use it. And here also the code, you can scan it with your phone. And in that case, you can get your credits. And here the third thing, if you cannot use your phone, you can follow the instructions on this slide and to be able to get your credits. Thank you for your time. We enjoyed the presentation, and thank you, Matt, for allowing us to work with you.
Thank you.
And we are looking for next year
Yes,
working
absolutely.
research. Thank you, and have a great day.